All right. So as you're looking at that reference sheet, looking at the reference of information, u prime, now continue to look on that sheet. Look at things like the cosine derivative and the sine derivative and the e to the x derivative, and look at several of those other rules. Do you see that u prime continuing to show up as a part of it? So really, all these rules are actually chain rule applications. We just hadn't been talking about what u prime had been. By the way, what was I making u prime prior to today? U prime had always been 1. I was forcing it to be a 1 so that you didn't have to worry about it. That is no more.
What?
That means I can choose whatever I want as a u prime now. So my world has opened up a lot more for what I can ask you.
How about you just close it right
No, now the world is opened up. Knowledge is out. We get to use more information. Isn't it great?
I know.
So let's try this.
Yeah.
Please find the derivative. Remember I said that door opened up. Let's walk through it.
Do you remember how I said close it?
No, it's not closed anymore. Hey, I do construction. I can take walls out. I don't even need doors. I can make windows that are big as doors. It's fine.
I still don't know that I'm willing to walk through those windows or walls.
Okay. Let's try it and see. Yeah, that's a big step that we're taking. Let's try it and see. Can you do that one? I know that. Don't be intimidated by what you think might be hard. Is that what it looks like? What's the derivative of the sine of x? So now does that make sense if we follow the steps the chain rule gives us?
What about the subtraction? Put in something?
When we're using the e,
Oh, it just
stays the same, yes. Okay? So does that make sense?
That's done.
I'm done with it. That's all I'm going to do with it.
And how'd you get u as the sign of?
Because I have to say, what is a rule I probably know? Well, I probably know e to some power.
Okay.
So that means if I don't know how to directly deal with that power, that is going to be my u, so I can hopefully get to something that will match. So if you look at your reference sheet or that sheet in the front of your book, please look at it. Find the one that is actually e to the u. Okay? Well, I always make stuff up. There's nothing at this point about it.
I'm looking at what?
The e to the u. And the question is, does the e to the u become this as a derivative? U prime, or probably it's e to the u times u prime. But the order of that multiplication isn't nearly as critical as the fact that we have the u prime in the problem.
So like u to the x, like instead of the x.
U is just x, the derivative is 1.
That's what.
That's why I say the same. Now I've got other u values, so I do have something that's not 1 as a u prime. Question? Any other questions? Okay. Well, that was fun. Let's try another one.
Yeah.
One of the things you're going to start recognizing when we do these is you have to decide what is the big operation function. In other words, what is the major rule that I'm working with or the major kind of function I'm dealing with. in this problem, is it 4x or is it sine of something? Do we have a rule for the sine of something? We also have a rule for 4x. We have a rule for the sine of something, correct? So you have to pick out which one is the rule that I'm hoping to apply once I make my substitution down here. Probably the sine of something, correct?
Yeah.
So that forces me to choose my u value to be what?
4x.
And therefore the derivative of 4x is
4.
So now, if I rewrite this, and I will tell you that once we get more familiar with these, we are not needing to rewrite them all the time. You'll be knowing about this in your head. But at the moment, we want to write it as sine of u. Now, according to our derivatives, when I have the sine of u, what is the derivative of the sine of u? And then what else is on there? There is a u prime that we have in our rules because we have to use that chain rule effect. So now let's resubstitute. So the derivative as x's is now the cosine, but what is u? 4x. What is u prime? And so then to kind of write it in a more formalized math version, we're going to say that the derivative is 4 times the cosine of 4x. Just like that. Do we understand?
Yeah.
Let's try another one. Wonder what kind of fun we could have with this one. Please find the derivative of this one. Don't forget, the concept of composition of functions may be in play. We may have to think about what is a function we put into another function through composition.
I know what it is already.
Oh, you do that before you say
I probably would. So what did I put into something else? Okay. And so that then tells me my derivative of 5x squared minus 3x is what? What?
Oh, 10x minus 3.
Okay. And if I rewrite my g function, it's going to look like what before I take a derivative? Would you agree that u to the 1/2? Does this make some sense? Okay. Can you now take the derivative of u to the 1/2? The chain rule says we need to include u prime in that. So we have just our power rule, 1/2, and then u to the 1 less power. But the chain rule says then we're going to have that u prime as part of this answer. Does this make sense? Okay. So g prime of x is that 1/2, and then the u value doesn't change. So 5x squared minus 3x is to the negative 1/2. And now we have that u prime, which we have found 10x minus 3. That would be a correct way to say it, yes. Now, some of you are going to want to rationalize the denominator because that doesn't make you very comfortable to leave it in the version that's written there. Others of you are going to go, I'll just leave it alone, it'll be fine.
Yeah. I'm not doing any more than that. Yeah.
Does this make a little bit of sense? Okay.